Hello everyone, my name is Oitro and today I'm going to be talking about class 9 to 10's physics books third chapter, which is entitled as force, and I'll be basically going over the whole thing today. So yeah, I'm covering the entire chapter. So yeah, we'll go through a lot of stuff like definition of force, effects of force, types of force, balanced and unbalanced force, inertia, etc. So yeah, let's get started. So what is force? Force means a push or a pull acting on an object. Simple examples can be like pushing a table, pulling a drawer, kicking a football, opening a door, etc. All of these involve force. Force can make an object move, it can stop a moving object, it can change speed, it can change direction, even change shape sometimes. Like squeezing a sponge changes its shape. So, yeah, you got what I mean. The SI unit for force is newtons. So, yeah, which is described or like shortened as N. So, yeah. It's basically its basic formula is F equals ma. It's like the inline formula. Basically, everyone knows about it. This is the basic one. So yeah. So 1 Newton is the force that gives a 1 kilogram object acceleration of 1 meter per second square. So yeah, that's like a thing to know. But you can get like 1 Newton force from other than just 1 kilogram of object and a meter per second square like acceleration. Like let's say zero point 0.5 meter per second square with a 2 kilogram object. That'll still give you like 1 Newton. So yeah, but this is basically a thing to know. So yeah, I just said it. So yeah, so second, we're going through effects of force. Force does not always makes things move instantly. Sometimes force can like change direction, change velocity, or deform objects. Examples can be a goalkeeper stopping a football uses force to reduce velocity to zero. A bat hitting a cricket ball changes both speed and direction. So force can basically the reason why motion changes. So yeah. So types of force next. So force is mainly divided into two categories. Contact force, which is basically forces that need physical contact. Muscle force produced by muscles, example like lifting a bag, pushing a cursor, etc. Another one is friction force, acts opposite to motion. Without friction, you couldn't walk, cars couldn't move, etc. So yeah, there's also like tension force, but yeah. Then there's non-contact force. There's like gravitational force. Earth pulls everything towards its center. That's why objects fall downward. Yeah, that's because of gravitational force. Then there's magnetic force, magnets attracting like iron objects, and electrostatic force produced due to electric charges, like when tiny paper pieces like stick to a charged cone. So yeah, and there's balanced and unbalanced force. Imagine two equally strong people pulling a rope from both opposite sides. The rope doesn't move. Why? Because the forces cancel each other. The inline formula is F net equals 0, so there's like no force to like move the object and all. This is called a balanced force. Balanced force cannot change the state of motion. Now imagine one side suddenly pulls harder. The rope moves, and then there's like unbalanced force. Unbalanced force changes motion, speed, or direction. So yeah. Then we have inertia, which is an important part of like this chapter. So yeah. Inertia means the tendency of an object to resist changes in its state. Basically, like objects are lazy. A stationary object wants to stay stationary. A moving object wants to keep moving. That's why when a bus suddenly stops, passengers move forward. And when it suddenly like increases speed or like starts, then you move backwards. Their body wants to continue moving due to inertia or wants to keep being stopped due to inertia. More mass means more inertia. So a truck has more inertia than a bicycle. That's why a bicycle is most likely going to be more damaged than a truck if they both collide. So, yeah. Then we have Newton's first law. First law says an object remains at rest or in uniform motion unless acted upon by an external unbalanced force. This is also known as the law of inertia. Example can be a football lying on the ground won't move unless someone kicks it. Yeah, so then we have Newton's second law. This law explains how force, mass, and acceleration are related. Inline formula is the same basic one, F equals ma. From this equation, acceleration increases with force, acceleration decreases with mass. Meaning, pushing a shopping cart is easy, but pushing a truck, yeah, you will be like not able to do it by yourself. So, yeah, because larger mass requires more force. Newton's third law at last. So, Newton's third law says for every action there's an equal and opposite reaction. Example can be gun recoil. If you shoot a bullet from a gun, then your hand will go backwards from the recoil. Then we have swimming, rocket launch. Yeah, rocket gases move backwards and rocket moves forward. Equal force, opposite direction. So yeah. And then we have friction. It's also an important thing to know about from this chapter. Friction is the force that opposes motion between surfaces. Sometimes friction can be helpful, such as when walking, riding, vehicle movement. Yeah, but too much friction wastes too much energy, produces heat, and damages machine parts. Some ways to reduce friction are like lubricants, polishing, wheels, ball bearing, etc. So then we have momentum. Momentum means the quantity of motion. Its formula is P equals mv, where P is momentum, m equals mass, and v is velocity. So yeah, a fast track has huge momentum. A tennis ball has much less momentum. So yeah. Then we have conservation of momentum. The law says total momentum remains constant if no external force acts. Example, when a gun fires, bullet moves forward, gun moves backward. This backward motion is called recoil. So yeah. And that's basically the full chapter done. I basically talked about the whole thing. I skimmed it down a lot, but yeah, I basically went over everything. And yeah, so thank you for listening to me today, and yeah, that's all.